Hello my dear students, as per our the last class, we discussed about the electromagnetic induction of the part 1. So, what are the tasks we have discussed there? Let us recapitulate it first. In your the electromagnetic induction, we came to know that if there is a change in its the magnetic field or there is a relative motion between your the conductor and your the magnet, then there is a development of your the current. As the earlier development of the current was only through your the battery, therefore, it was your the cost effective one. But now the development of the electromagnetic induction concept, if you just change the relative motion, suppose this is your the coil and this is your the magnet, and you sit at a position, keep a coil at one place and you take your the magnet towards it or away from that one, then some current to be the developed. So, that type of the currents nowadays it is used in a lot of the manner, therefore, it becomes your the so cheap. So, about that one, the concept was given by your the three persons. One is your the Faraday, second one is your the Newman, and the third one is your the Lenz. About your the Faraday's observations and its the experimental evidences with its the laws, we discussed here the three laws, and in some books you will find that is the two law. So, as per my discussions, if you will combine your the first law and the second law, that will be your the one, and here the third one which gives its the induced EMF, but its the magnitude was given by your the Newman, therefore, the Newman's name is also attached there, but mostly the lion's share being taken by your the Faraday and your the Lenz, therefore, it is known as your the combined of the Faraday's and the Lenz law as your the E is equals to minus of the d phi by your the dt. So, the Lenz law provides the direction of the induced EMF and the Faraday's law gives the magnitude of your the induced EMF, and by using that induced EMF we can find its the current. So, that induced EMF and the current expressions for your the induced EMF we have written as the motional EMF. So, motional EMF means due to your the motion. Suppose a conductor is moving with the certain speed v, then it is the motional EMF as we discussed E is equals to your the BVL. These are your the recapitulations of your the last task, and today we are going to discuss about your the motional current, the eddy current, the self induction, mutual induction, and regarding these two, what are the questions that are generally coming in your the council examinations or in your the CBSE examinations. So, let us now start from today by taking your the motional current. Motional current. So, you know that I is equals to your the q by t, or that is equals to your the dq by dt also. This is the expression of your the current. So, whenever the current is there, there must be your the some charge, and by taking that charge you will find it's the current. Also from your the Ohm's law, V by I is equals to your the R, implies V is equals to your the IR. So, V means your the potential. That potential if you will take is your induced EMF. Suppose you will write it is the symbol of your the J, induced EMF, or in books you will also find that is equals to the E. Suppose the E is there and the charge of the electron is also the E. So, there is a dilemma. Therefore, if you will take is the J, so that is equals to your the IR, means your the I is equals to your the J by your the R, means this is your the induced EMF by your the R. And if you will say this current as your the motional current, then this induced EMF will be your the motional EMF by your the resistance R. R means your the resistance. So, in this way we will find the expression of your the motional current. You see, on your the screen you will find that suppose you have a magnetic field, and that magnetic field we have written as your the cross mark. Cross mark means it is your the inward magnetic field, and we have taken a conductor which is given in your the rectangular long form, and that conductor is moving with the certain speed of your the v. Then it will produce your the motional EMF, and that motional EMF will automatically it will give you the motional current, and that motional current I is equals to your the Chi by your the R, and on your the paper on your the screen you also find that I is equals to your the Chi by your the R. So, what is your the Chi? This Chi is your the motional EMF, and we know that that motional EMF is equals to your the VBL. We developed Chi is equals to your the VBL, or that is equals to your the V vector cross B vector dot of your the L vector. That we find out in our the last class. So, this motional current, if that to be the written as your the I, then this is the motional EMF. Motional EMF is equals to your the VBL by your the resistance. If resistance is equals to your the R, then I is equals to your the VBL by your the R. This is the one of the expression of your the motional current. So, whenever a current will pass through your the conductor, means as we have taken, this is your the inward field in which a conductor is taken, and that is moving with the speed of your the v. This is its the length of your the L. So, when it will move in a magnetic field, automatically your the motional EMF is produced, as we came to know already, because when it will move from this position, suppose it will come to this position, there is a change in area. This change in area will lead towards the development of your the phi, and that phi means there will be your the EMF. EMF is equals to your the d phi by your the dt. Likewise, we find Chi is equals to your the VBL. So, if this is in its the motion, means it produces a field, and that field is opposing to the cause which is already make for it. Means the kids kills the father, as we came to know that if this is the inward, the electric field which will produce a force, that force F is equals to, in a magnetic field due to the conductor of the length L through which the current is your the flowing as your the I, then we came to know in the magnetic effect of the current F is equals to your the BIL. So, if this F is equals to the BIL, then in your the motional EMF, it leads to your the motional current. So, motional current means your the I. If the motional current will be your the I, then what will be? It's your the motional force. So, this motional force is equals to your the B of I is equals to your the BBL by your the R into your the L. That is equals to your the B square L square V by your the R, that is equals to your the motional force. So, this is its the motional force. You see F is equals to your the V of your the L square B square V by your the R, that is your the motional force. So, this motional force will leads to your the development of the another current which is known as your the ED current, that is known as your the ED current. This ED current is developed due to your the breaking of the motion. This breaking of the motion will leads to your the Lenz's law and your the Faraday's law. Faraday's law. And these braking means, suppose in your the vehicles some brakes are there, during that brakes, if the brake to be the made your the very speedily with its the tight position, then some currents will be developed, then that is known as the ED current, and for which we are saying that there is a breaking of the currents will arises, and that is generally arising in case of your the large instruments which are moving with its the greater speed and some brakes being the applied to that one. So, during that one, that eddy currents is of your the two types. One is the circular eddy current and another one is the linear eddy current. Circular eddy current means the shape of your the circular one, and the linear means there is a line one. So, the linear ones are generally you are finding in your the trains, and your the circular one, like in case of your the 4-wheeler, 6-wheeler, they are your the breakdown voltages which we are saying. So, that is about your the eddy current and your the motional currents. By taking these eddy currents and the motional currents which are your the developed, that developments are leads to your the two different types. One is called it's the self induction, and another one is called it's the mutual induction. So, they leads to your the self induction and mutual induction. So, from the name it being clear, self induction, that is the SCLF self, not it is your the SHELF self. SHELF, what you know very well, this is the self. Self means your the own, the same person or the same thing, or you are the same one, which one thing is your the induced, that is your the self induction, and this is also known as your the motivational method. This is your the motivational method, means that to be your the motivated, from its the mood to your the motivated. So, what is developed only the same coil or on the same conductor itself, then that is your the self induction, and the mutual means among your between your the two things. If something is developed in your the one and the similar type of the thing is developed in your the second one, then that type process is known as your the mutual induction. So, let us now first go for your the self induction. Self induction. So, we have taken a coil. So, it has its the number of turns. So, 1, 2, 3, 4, 5, 6. So, 6 turns we have taken, and if it is placed in a magnetic field or the some current to be or the flows through, means it is placed in a inward field. If it is placed in a inward field, there is your the no change, but if you will connect it with a battery, suppose you will connect with the battery, means some charge to be or the flow through it, and when the charge to be or the flow through it, what will happen? There will be a change in its the field. So, when the field to be or the changed, means there is a change in its the value of the B. So, when the field to be or the changed, then there is a change on its the flux, and due to the change on its the flux, as we came to know that when the flux will be changed, then there will be the induced EMF. There will be a induced EMF. So, when the induced EMF will be there, then there will be the current. So, some induced current to be the developed here. So, the induced current which is developed here means what will happen? So, inside this there is a current. So, inside this you will find automatically a current will develop, which is called here the induced current. So, this is the induced current. So, this induced current factor means I is equals to here the V by R, that is equals to here the epsilon by here the R. So this I means this induced current is purely depends upon how it's the magnetic field being here the changes. So when the magnetic field being here the changes means if the phi to be or the more, then the current which is developed through that conductor, that being here the increased. So within the same one, if there is a change in its the magnetic flux, there is a change in its the current. So this phi is proportional to your the I, means that phi is some constant of your the I. So that implies the phi is equals to some constant of your the I. So phi is equals to your the Li, where L is known as coefficient of self-induction. Coefficient of self-induction or self-inductance. This is the generally symbol which is used for your the coefficient of your the self induction, and if the phi is there, automatically the Lenz law to be the applicable, and when we will go for its the Lenz law and the Faraday's law, another expression of the self induction will the arise, and that we will came to know later. As we came to know that for your the self induction, if this is a coil connected with your the some source, and if you have connected with your the key arrangement here, by controlling this key arrangement, the flow of the current to be your the control, means the flow of the current if under our the control, that flow of the current either it will increase or it will be your the decrease. If it will increase, there is a change in the magnetic flux. If there is a decrease, there is a change in the magnetic flux. That magnetic flux will leads to your the phi. So phi is equals to your the Li. But what is the direction? When it will increase, means your the self inductance will your the decrease. When it will decrease, and it will your the self inductance will your the increase. So if phi is equals to Li, and we came to know that if phi is there, there is a induced EMF. Induced EMF is equals to your the d phi by your the dt. The second expression we are going to find, because here L is equals to your the phi by your the I, and now it is E is equals to d phi by your the dt. So if it is d phi by dt, so d by dt, what is the phi? You see phi is equals to your Li, Li. So Li. So that is equals to L. L is the constant comes out, and that is equals to your the di by your the dt, means your L is equals to E upon di by your the dt. So L is equals to E upon di by your the dt. Here L is equals to your the phi I. These are the two different expressions of your the self induction. By taking that two expressions, we will find what will be its the unit, what will be its the dimension of your the self induction. So how will you come to know what will be the unit and what will be the dimension? So the unit and the dimension, as I said in my earlier classes, that purely depends upon its the mathematical expression. So if L is equals to your the phi I, means when phi is near the some unit and I is near the some unit. So here the I we have taken as the capital, and let us take this is equals to also the capital I. So if phi means your the magnetic flux, and the flux unit I said that is your the Weber. So if that is in the Weber, and I means your the current is in your the ampere, then what will your the L? L is equals to your the phi by I, that is equals to your the Weber by your the ampere. This Weber by ampere is known as your the Henry, and which is written as your the capital H. So the coefficient of the self induction is equals to your the 1 Henry if I is equals to your the 1 unit and phi is equals to your the 1 unit. Then L is equals to your the 1 unit. If this I 1 unit is equals to your the ampere, phi 1 unit will be your the Weber, then I 1 unit will be your the Henry. Hence, coefficient of self induction is equals to 1 Henry, means L is equals to 1 Henry. When the flux this amount will produce the current this amount. When the flux of 1 Weber produces the current of 1 ampere. This is the definition of your the Henry, which you will find in your the +2 as the short question, define Henry. So you have to write it's the Henry. So when the question is coming define Henry for your the 2 marks, you first write it's the definition, then it's the dimension also. By giving you the dimension, you will get your the 100% of the marks. So this is your the Henry for your the this definition. So the same L is defined as the E upon di by your the dt. So if it is E upon di by dt means when E is what? I said E is your the EMF. EMF means your the voltage. If E is equals to your the 1 volt, di by your the dt, di by your the dt means 1 ampere by second. Then this L will be your the this L will be your the E by di by dt, E by di by dt. So 1 volt by 1 ampere per second. So this is also your the 1 Henry, that is your the capital H dot. You see the Henry is equals to Weber by ampere. Here Henry is equals to your the volt by your the ampere by second. So this volt by ampere by second you can also write volt into second by ampere. You see it is your the Weber by your the ampere, Weber by ampere, and this is your the volt into second by your the ampere. This Weber by ampere is your the Henry. This volt second by ampere is also Henry. So these two are correspond for your the Henry. You see here the denominator is ampere, here the denominator is ampere. These two R stands for the Henry. This is the ampere, this is the ampere. So this is divided by your the ampere, this is divided by ampere is the 1 Henry. So what you will guess now? This Weber and this volt into second, they two be are the same. So Weber is equals to your the volt into your the second. So this is also you will find as a short question. So 1 Weber is equals to your the how much in terms of the voltage, or in terms of the second the question will come. But if the question will come define your the Weber, Weber means that is the phi. Phi is equals to your the BA. So one can write the B into your the A. B means your the magnetic induction, that is the Tesla, A is your the meter square. So if the question will come define Weber means if you write Tesla into meter square, that is your the okay, and if you write Weber is equals to volt into second, that is also okay. But if the question will come indirectly define your the Weber in terms of the voltage, or define your the Weber in terms of the second, so you have to write Weber is equals to your the volt into your the second. So if this Henry is looks in your the volt second by ampere, and this looks your the Weber by your the ampere, they are of the different names. But if they are the different corresponding for your the same one, but they must have your the same dimension. So if the dimension you will calculate, this is the Weber. Weber means your the phi by your the I. Phi is equals to your the BA by your the I. B is equals to your the F by your the IL into A by your the I. That is equals to F A by your the I square L. Now put the each and everyone's dimension. force dimension ml t to the power minus 2. A dimension will be your the L square by I dimension is equals to your the ampere square into your the capital A square of your the L. You see this L will cancel. So, m L square t to the power minus 2 a to the power of minus 2 from this definition. If we go for this definition, that is equals to your the volt into second by your the ampere. So, volt means V is equals to W by Q, second is equals to your the time. So, volt by time into your the ampere is equals to your the A. So, that is equals to V T by Q A. So, V is equal to W T by your the Q A. W is equals to your the ml square t to the power minus 2, T is equals to 2. So, I. So, I is equals to your the Q by T, Q is equals to your the IT, I means your the A, T is the capital T into your the L square. So, what it will be here the now you look m I is equals to Q A T into the A is equals to the ampere, this ampere is equals to the A itself. So, that is equals to the m L square T is the cancel. So, now it is the t to the power minus 2, A into A is the A square. So, that goes up. You see, this is the ml square t to the power minus 2 a to the power minus 2, ml square t to the power minus 2 a to the power minus 2. So, both dimension are same means these two are here the same. So, this is about your the self induction. So, the self induction is that process where the induced EMF and the current is produces in the same coil. If it will the increase, then that will decrease its the induced EMF. If it will decrease, then it will increase its the induced EMF. Now, we are going to discuss about the mutual induction. It is the two words mutual and induction. Induction, we came to know that without touching is your the induction. As you know in your the electrostatic chapter, the charging of your the uncharged body is of your the two process. One is the conduction process, second one is the induction process. In the conduction process, we have to just connect them, but in your the induction process there is no connections, but the effect of the one being your the existing in your the second, then that is called your the mutual. So, as our the in general way, suppose some conflict being your the arises, then we are taking here the first advantages of solve to that one, that is your the mutual understanding, means between the persons if some difficulties being arises, by using them means by taking the opinions of the them, we will first try to solve that one. So, that type of the mutual word you know. So, here we have to discuss about the mutual induction. Before we came to know about the self induction. In case of the self induction, self means your the individual. So, when a individual conductor or the coil being taken and some current to be the flow and its variation will be maintained there, then a current is developing there, and that current is known as the induced current, because due to that the flow of the current there is a change in the magnetic field. So, whenever a magnetic field being the changed according to the Faraday's and the Lenz, we came to know that there is a current, and that current will oppose that one. Therefore, we came to know that if the resultant field inside your the coil being your the increased, then the developed current being opposes to that one. That we discussed for your the one coil, and here we are going to discuss by taking your the two coils. So, when the two coils are to be taken, one will taken as your the primary and the second one will taken as your the secondary. So, on your the screen you will find your the two coils. So, if you will change your the current in your the one coil, then automatically in the second we will develop your the another one. Means how this is your the happens? So, mutual. So, in your the business also you are saying that due to your the mutual understanding, your business is going well, and due to the lack of here the mutual understanding, your business is going down. So you have to take in 2 coil. So this is the one coil connected with your the source of the alternate. This is your the second coil, it connected with your the galvanometer. So there are the 2 coils. So this is your the first coil. Let us take the first as your the primary. This is your the secondary. As we are saying that the primary education means your the starting one, the fundamental primary, then it's the higher form is it's the secondary. So this is your the first coil in which we have to control the flow of the currents. So due to the flow of the currents, it will produce here the, suppose the lines of force it produce, and that lines of force will affect to this one. This will affect to this one. When it will affect to this one, then you will find that in your the galvanometer there is a deflection. In the galvanometer the deflection you will find. So if the deflection in the galvanometer, what it indicates? In the second coil, some current being here the developed due to the deflection in your the galvanometer. Suppose this galvanometer will provide a deflection likewise, or provide a deflection likewise. So by taking that deflections, we came to a conclusion that when some current is flowing this primary, the development of the current in your the secondary. So if this one is connected with your the key one, by controlling this key, the flow of your the lines of force will also your the vary. So from here it is clear that due to the variation of the current in your the primary, there is a variation of the current in your the secondary. So when in the secondary the current being the produced, it shows that here also there will be the some change in its the magnetic flux. So if some flux is proportional to your the I, as we came to know, so if there is a change in its the current, then there is a change of the flux in your the secondary. Or in the reverse way, suppose one will take in this one, the current will be your the there. So if this is equals to the phi I, then this is equals to your the Is. So there is a change in here, there is a second one there. There is a change in there, if that will be the primary, here it will be the secondary. So if phi proportional to I as for your the self induction, both are happened in the same coil for the self induction. But for the mutual induction, if the change in your the primary, it will indicates there is a change in its the secondary. So this phi is proportional to I, implies this phi I is equals to some constant of your the I, and if this is the phi I, this is the Is. For your the betterness I am saying, this is the input, this is the output, this is your the primary, this is your the secondary. So this is the phi I is equals to your the some constant. Here that constant is taken as your the capital M. So this is equals to your the MIS. You see MIS. But if you say that phi I is equals to your the miss, then it will be the remember very well. So phi I is equals to your the miss, MIS. But this S is not stands here on the right, it is on your the denominator, MIS. So this shows that M is equals to phi I by your the IS. So, means if there is a change of a flux, then there is a change of the current. So, if the change of the current is occurring in the secondary, the flux change is occurring in your the primary. So, phi I by your the Is is equals to your the M. This is one of the definition of the self induction, definition of the coefficient of your the induction for your the secondary one, and this M is treated here as coefficient of mutual induction. Here it is called the coefficient of your the mutual induction, means M is equals to the phi I by your the Is. But for the self induction, we have taken L is equals to your the phi by I. For your the self, you just look, both are your the looks your the similarities. Here phi by I, here also phi by I. For the self, only that is the one, but for the for the mutual case, one is your the current, means in another case there will be the change of the flux. So, if this is your the one of which is the expression, for it is the second type of the expression. For the second type of the expression, you know that phi is equals to E is equals to d phi by dt. So, that is equals to d by dt of your the phi. So, phi is equals to how much? So, phi is equals to your the MIS, as we have derived. Phi is equals to your the MIS. M is the coefficient of the self induction, that is a constant comes out, then that is equals to DIS by your the dt. If this is the DIS by dt, then M is equals to E by DIS by your the dt. This is for your the mutual case. But for the self induction case, L is equals to E by di by your the dt. So, this is for your the mutual, and this is self, this is your the mutual. And the primary definition was M is equals to your the phi S is phi I is equals to MIS, this is one, and for this one phi is equals to your the Li. Just I am comparing the self and for the mutual. If for the self this is the induction is the L, here it is the L, so phi is equals to Li. For your the mutual, that is your the M, so phi is equals to Mi. This is the Li, this is the Mi. But for the mutual case, you always mention the primary and the secondary conditions. Therefore, this is your the phi p, suppose you will take for primary, for the secondary that is equals to the S. So, this is equals to the MIS by your the dt. So, these are the two definitions for them. So, for your the unit, now we will discuss what will be the unit. So, here M is what? Coefficient of a mutual induction. Here L is what? Coefficient of your the self induction. So, if we will go for your the unit, let us come for your the MKS first, or which we will say generally that is of the SI. So, how will you find the unit? By taking its the mathematical expression. Let us now go for its the first case. For the first case, for first formula, for the first formula, phi p is equals to your the MIS. Phi p is equals to your the MIS. If phi p is equals to your the MIS, for the formula you will take for your the mathematical expression. Phi p is equals to MIS means when phi is equals to 1 Weber and phi p, and this Is is equals to your the 1 ampere, implies M is equals to phi p by your the Is, means 1 Weber by your the 1 ampere, that is equals to your the 1 Henry. This is equals to the 1 Henry. So, how will you define the coefficient of the mutual induction as the 1 Henry? Hence, coefficient of mutual induction is said to be 1 Henry when the magnetic flux of 1 Weber in primary produces the current of 1 ampere in secondary. You see, when phi p of the 1 Weber and current of your the 1 ampere. So, that is your the 1 Weber in your the primary and the 1 ampere in your the secondary. So, this is for your the mutual one. As I said, for the mutual one, you have to mention the two terms, primary and the secondary. But if there is a question only define, question is only define Henry. Question is only the define Henry. So, for your the self induction, we define the coefficient of the self inductance as the Henry, and for the mutual induction, that is also the Henry. So, the students, you must be in the dilemma for which definition we will write, either for your the self induction or for your the mutual induction, but the choice is your. If you will write for your the self induction, there is nothing to write about the primary and the secondary words, and if you will remove that primary and the secondary word, that will correspond for your the self induction. Suppose I will remove here the primary and here the secondary. Then what I had written, hence coefficient of, instead of the mutual induction, you will write here as your the self induction is said to be 1 Henry when the magnetic flux of 1 Weber produces the current of 1 ampere. This is the definition of your the Henry. Suppose one will try to write it in the mutual condition. For the mutual condition, the statement will be the coefficient of mutual induction is said to be 1 Henry when the magnetic flux of 1 Weber in primary produces the current of 1 ampere in secondary. Are you clear, my students? The choice is your. Either you will correspond for your the self induction or you will correspond for your the mutual induction. That is your work. So, regarding your the first expression, we defined your the M case 1. Similarly, we will go for your the CGS and for your the second definition also. As per our discussion, M and your the L, M for your the mutual, L for your the self. The mutual definition for your the M is equals to E by dis by dt, and for your the L is equals to E by di by dt, and for its the primary definition phi p is equals to your the mis or phi is equals to your the li, and we already started about its the unit for your the SI. Suppose you will go for your the EMU. Sir, what is EMU? Generally we are writing CGS. So, CGS is of the two types. One is the ESU, one is the EMU. ESU means electrostatic unit, EMU means electromagnetic unit. Here, though the magnetic fields are having its the vital roles, so for your the CGS we will write for its the EMU on the same way. So, how, when phi p is equals to Weber will be your the Maxwell. This is your the Maxwell in your the EMU, and generally that is written as your the max, and your the Is is equals to your the 1 ab ampere. Then M is equals to phi p by your the Is is equals to 1 Maxwell by your the 1 amp-ampere is equals to 1 amp-Henry, and this is equals to 1 AB capital H, 1 amp-Henry, that is for your the EMU. Similarly, if you go for it, see the total descriptions detailing one, the coefficient of mutual induction is said to be, instead of the 1 Henry, that is the 1 amp-Henry, when the magnetic flux of the 1 Weber in primary produces the current of 1 ampere in the secondary. Only there of the 1 amp-ampere, this ampere will be the amp-ampere. So, what are the changes? Ampere becomes your the amp-ampere, and your the Weber becomes your the Maxwell. So, when this is your the said to be your the 1 amp-Henry, when the magnetic flux of the 1 Weber means that is the 1 Maxwell in primary produces the current of 1 amp-ampere in your the secondary. This is for your the such definition. If we go for it, see the second definition. For the second definition, M is equals to your M is equals to E by dis by dt. For this one, if we go for your the M case. So, M is equals to E by dis by dt means when E is by dt. So, as I said that to find the unit of your the any one, you will follow its mathematical expression. The mathematical expression is the this one, E by dis by dt. When we are going for your the M case, we have to choose the unit of the E in your the M case, unit of the dis by dt in your the M case. E is what? Induced EMF. EMF means your the volt. So, here the unit will be your the volt, because it is your the M case. If we go for your the EMU, that will your the amp volt, and dis by dt, I means your the current, T means your the time. So, this is equals to your the ampere by your the second. So, when this E is equals to this is equals to this, we are interested to know what is the value of the M. So, M is equals to E is equals to your the 1 volt by dis by dt means 1 ampere by your the second. So, this is equals to 1 volt into second by your the ampere. So, this is also your the 1 Henry, that is equals to 1 capital H you will write. So, this is your the mutual induction is 1 Henry. So, how the definition will be like here? The coefficient of mutual induction, M dot I means mutual induction, is said to be, So, what is the unit of the mutual induction? 1 Henry is said to be 1 Henry. Only you remember the formula. According to your the words collection, you will write its the definition. So, it is said to be the 1 Henry. So, when it is said to be the 1 Henry, when the potential of your the 1 volt, which to be your the produces the current of your the 1 ampere by second. So, it is said to be the 1 Henry when the induced EMF of 1 volt in secondary, in primary, this is the EP, in primary will produce the rate of change of current as 1 ampere by the second, because dis by dt rate of change of current, that is the ampere by the second in secondary. This is for your the mutual induction. So, if this mutual induction will replaced by your the self induction, For here the self induction, as we discussed, for the self induction what will be? Here M will be here the L, this EP will be here the E, this IS will be here the only I. But the same expression is the same. Here L is the this one. Instead of the L, if you will take the M, E will remain such, but the two different names will arise. One is your the primary, second one is the secondary. If this is the primary, then this is the secondary. This is its the definition for your the M case. If you will go for your the EMU, just remember here the mind. How we will follow for the EMU? Likewise, in your the M case, only you have to change its the values in your the different numerators and the denominators. You see, in the numerator it was your the E. E means your the volt. If you will go for the EMU, this volt will your the EMU, means this is equals to your the 1 amp volt. Similarly, dis by dt, dis by your the dt is equals to ampere by second, means 1 amp ampere. Sir, the question is, sir, why not it is the amp second? The time is always in M case or the CGS, that is the CGS, there is no variation. So that is the amp ampere by second. So if we put the values are here, EP is equals to the 1 amp volt, this is equals to 1 amp ampere by second. So this M case will be the EMU. So this is equals to the 1 amp volt by the 1 amp ampere by second. This is the 1 amp volt by the 1 amp ampere. And this Henry will also be replaced by the same way as your the amp Henry. Therefore, the definition will be coefficient of the mutual induction is said to be the 1 amp Henry when the induced EMF of 1 amp volt in primary will produce the rate of change of current as 1 amp ampere by second in your the secondary. So if you remember only these two formula, and by taking the unit of the individual things, you can write what will be the unit of that one. Not only for this one, but for your the each and the every mathematical expression, if you remember the unit and dimension, you can easily find out. So the second task I am giving to you, that if it is in the M case and another one is the EMU or is the CGS, then there is a relation between your the M case and your the CGS. So what is the way to find the relation between M case and your the EMU? You will first take your the M case, what is the formula you write, and convert each and the every one to your the respective CGS. Suppose you will go for your the M case, E will be your the volt by this is equals to your the ampere by your the time is equals to your the second. This is the first thing you have to write, and you have to convert it for your the EMU, means this volt to be converted to your the amp volt. So the volt is not directly converted to the amp volt. Likewise, if you have the 1 rupee, one will say you convert it to your the paise, means this 1 rupee will not your the 1 paise, that will your the 100 paise. Similarly, the volt and the amp volt, what is the relation you know earlier, ampere and the amp ampere you know earlier. So put that values, then you will find that 1 Henry is equals to your task, that is equals to your the amp Henry. This is your task, and you find out, and that value and that result if you put me in my comment, then I will give either it is correct or wrong. This is for its the unit. Similarly, as we find out its the dimension, you will go to find its the dimension also. Both are looks your the different in your the unit way, but in the dimension way it will your the same. So by taking these one, different questions you will find in your the council examinations, find your the define your the mutual induction and write its the different units, or define your the self induction, write its the different units, or the question will come what are the Faraday's laws of the electromagnetic induction, and apply it as your the Lenz law. Is the Lenz law will satisfy the conservation of the energy? Different questions you will find. Likewise, you go through it and make here the hard preparation for that one, because your the examination is coming nearer and nearer. Thank you very much, my dear students.